All right, now this is still section 1.3, but we're getting into different types of numbers and like how they're related to one another. And we're going to learn different names for different types of numbers like natural or integers or irrational. Okay, so that's still in section 1.3. All right, what I want to do first is look at putting these numbers that you see on a number line. Clean that up a little bit. Just get that out of the way. All right, and then when you're looking at that, that's a whole bunch of numbers. The commas are separating the numbers. Okay, so let me just exaggerate those commas. All right, so we have a whole bunch of numbers we're trying to put on a number line. So take a minute and draw a number line, put 0 in the middle, and then make tick marks. Let me spread it out even a little bit more. I think I have room. I really only need to go to about 4. I think that was the biggest number I used. So I have room to go pretty far. I can go all the way to 4, cut it in half, half again. So that would be 2, that would be 1, that would be 3. Okay, and then do the same on the other side. But see, once you've decided on like how big you want one unit to be, you have to be consistent when you label that. So I need to be sure to use that over on this side as well. That looks like I need to go a little further, and there would be -4. Right, so -1, 2, -3, and -4. Okay. All right, so we're going to just go put these numbers on the number line. All right, so here's my number line. And then I'm going to go take each number and figure out its location. And I like to do this because sometimes we really don't have good number sense, especially about fractions and decimals. And I want you to know they're just a name for a location on this number line. They represent a quantity of something, okay? So 3 is pretty straightforward because it's actually one of the tick marks. So is the 0. Cross those out. We did those two. Another one we can do pretty easily is like -4, -1, because they're right at a nice tick mark, right? Then the others have a little more we have to think about. So when we're trying to figure out what to do with 3/4, sometimes people make the mistake of thinking it has to do with the 3 and the 4. But it doesn't. Okay, if you cook, you're used to using 3/4 of a cup. 3/4 really means 3/4 of 1. It really means that you got something less than 1. It's not even a full cup. You know, like think about a more common fraction, like a half. You work with half a lot. So half is the same as the decimal 0.5 or 0.5, and that's really the same as 50%. All of those mean the same thing. They all mean a half, and they all have one location on the number line, which would be right here. Okay? All right, now 3/4 is actually like you're taking this unit from 0 to 1 and breaking it into 4 equal pieces. This would be, the first tick mark would be 1/4, 2/4, and then that would be 3/4. Okay. So there's your 3/4. Okay. All right. Now 1 and a fifth. 1 and a fifth. See that 1, that whole number part means you're got to go past 1. And then 1/5 means this. It means if I could, and it's hard to do, but if I can evenly break that up, it's pretty good, into 5 equal pieces, I would go to 1 past it. So that right there would be 1 and 1/5, right there. Okay, then that would be 1 and 2/5, 1 and 3/5, 1 and 4/5, and then I'd be at 1 and 5/5, so I'd really be at 2. Okay. Right now, let's think about -3.5. Okay. Some people put it here, but that would be incorrect. You have to go all the way to -3 and then past it by a half. So it actually would be between -3 and 4. Halfway between -3 and 4 would be -3.5. Okay. All right. Let's look at 1 1/2. 1 1/2. 1 1/2 means, let me do this one in blue since I already have something in that region. 1 1/2 would mean you go all the way to 1 and then go halfway to 2. So it'd be right there. That would be 1 1/2. That would be the same as 1.5. Right? All right, let me go to green because I got another number I need to put in there. Okay. Now I'm being asked to do 1.2, and that's really not the way to read it. 1.2 is really, when you say it, it's 1 and 2 tenths is how I'm supposed to read that. We just get lazy. It's 1 and 2 tenths. The 2 is in the tenths place. What that means is it's like I go past 1 and I split this space from 1 to 2 into 10 parts, and I go to the second one. So it's like each of these would be cut in half again. And I go to the second one. So actually, I'm going to turn out to be right there at the same spot as 1/5. See, 1 and 2 tenths is really the same as 1 1/5. So that was just a different name for that same spot. Okay. All right, now square root of 9 is what number times itself is 9. Square root of 9 is really the same as 3. So that's just a different name, but it's that same location right there. Okay. All right, and -7/2 is also already on here. It just has a different name associated with it. This is an improper fraction. It has nothing to do with 7 and 2 individually. It really means 7 divided by 2. So if you divide, I'll do it up here. If you divide 2 into 7 by hand, it would go 3 times. There'd be 6 that you would take away. So you'd have 1 left. So -7/2 is -3 1/2. You also could use your calculator and just do 7 divided by 2 on your calculator and write it as either a decimal or a fraction. It would either show up as -3.5 or -3.5. So we already have that on here. It's right here. It's just that -7/2 is the same location. I just used a different name for it. Okay. So numbers can be written as fractions, decimals, percent, and you're not changing the number when you do that. You're just changing its name. It's just like a name and a nickname. Okay. All right. Now, the last part of this is where we're going to be looking at the different names for different types of numbers. And then we're going to come in here and we're going to try to list which of the numbers out of that set are natural numbers. I've got an extra comma here, so let me get rid of that. All right. And then which of those are whole numbers, which are integers, and so on. Okay. So I've got a chart that we're going to fill out, and I put a completed version of that you can go look at, and then we'll go back and we'll work this problem, which is like the ones you have in homework. I'm going to emphasize those commas. That's what's separating the numbers. Decimal points are just part of a number. Okay, so we have all those to figure out. Okay, so let me pull up a real number system chart, and we're going to put some labels on that. Okay, so first off, real numbers are composed of the rational numbers together with the irrational numbers. Okay, so all of those together would make up the real numbers. All right, and real numbers are what we're talking about when you have a number line. It's a real number line. And so that means every spot on that number line has a real number that you could associate with it, and every real number has a location on the number line. It goes both ways. So before I show you examples, let me get the names of the other numbers on here. So this next box The numbers inside it would be called integers. Okay. And then the next one, the numbers inside it would be called whole numbers. And then the numbers inside the next box would be natural numbers, is what they're called. Okay. All right. All right, now, the way these boxes are supposed to represent is if a region is completely contained within another one, then it's telling you the relationship between those two number systems. So like the natural numbers are completely contained within the whole numbers. So natural numbers, every natural number is also a whole number. It's also an integer, and it's also a rational number, which means it's real. So rational numbers are not just the numbers in this area, they're the numbers anywhere in any of those boxes. So like all natural numbers are whole numbers, all integers are rational numbers, etc. Okay, but then see how the irrational number box is completely separate from the rational number box? There's not an overlap between those two. A number is either going to be rational or it's going to be irrational. It's not going to wind up being both. Okay. All right, so let's go ahead and just start with natural numbers. They're numbers like 1, 2, 3 on up. Very nice, no decimal parts. Okay. Sometimes the number could have a different name, like square root of 16 would be there because it's really 4. A number like 8 halves would be there because it's really 4. So they can have a different looking name to start with and still be a natural number. Whole numbers would be all of those that you see together with a 0. That would be what makes it what makes whole numbers. 0 and then 1, 2, 3 on up. Right now, when you get to the integer box, what we're going to do is throw in the negative natural numbers. We're going to put negatives on those. So we're going to do -1, -2, -3 on down. Those are integers, but so are 0, 1, 2, 3 on up because those boxes are completely contained within the integer box. Okay. Now, what goes around the edge of that, the types of numbers that are rational but aren't integers, are the ones that can be written as a fraction. You know, any number that can be written in the form a over b, where these right here are nice integers. Any number that can be written in that form belongs in the rational number box somewhere. And so in this outside little region, that's where you'd have things like 1/2, things like 7/3, things like -0.75. And your decimal sometimes even looks really weird, like it might have that notation, which means the 1/3 gets repeated. Okay, that would be in the rational number area because that's really equal to, that turns out to be the same as -2 and 13/99. So it can be written as a fraction as well. Let me see. Let me put one more. Sometimes you can have things like square root of 25 over 9, which would really be 5/3. Square root of 25 is 5, square root of 9 is 3. So it would belong in this region as well. Let me see if I can write it up higher. Put it here. If you had square root of 25 over 9, that would equal 5/3. So it would be in that area as well. All right, and then like square root of 16, we talked about being really a natural number because it would simplify to be 4. If you had negative square root of 16, that would be in this area where you can have the negatives on stuff because that equals -4. Okay. Now, one type of irrational number would be numbers like square root of 7 or cube root of something like 10, where that's the 7's not a perfect square. So if you tried to do this on your calculator, it's a decimal, and it's a decimal that goes on and fills up the whole entire screen. Okay, so for instance, the square root of 7, let me look at that. That one turns out to be, let me move this one down. Square root of 7 turns out to be about, still an approximation, 2.6457 5 1 3 1 1, and there'd be more to it. We just don't see the pattern there. Okay, but the decimal would go on and would not terminate, and it would not repeat. Those are the kinds of numbers that belong over here. Okay. Cube root of 10. Okay, that's not a perfect cube. So that's going to turn out to be something that would be a decimal that would go on forever, and the best I could write down would be an approximation for it, and I'll tell you what it is. Okay, it is cube root of 10. Okay, that would turn out to be around 2.15 if I rounded to 2 decimal places, and then you'll see the whole screen of your calculator getting filled up. So the best you could do is a decimal approximation. All right, so irrational numbers are really non-repeating, they don't repeat, and non-terminating, they don't stop. Decimals that don't stop and don't repeat. That's what belongs over here. That's what makes them irrational. Okay, some others you know about are numbers like pi. See, because the decimal keeps going forever, sometimes they just name it rather than giving you the decimal approximation. It's about 3.14, or another common approximation is 22/7. E is another one that is used in math quite a bit. It's called Euler's number, and that's about 2.72. And then you also can have a decimal as long as that decimal keeps going and doesn't repeat. So like, how about 1, 0, 1, 0, 0, 1, 0, 0, 0, 1. See what I'm doing with those zeros? I'm increasing the number of them, which allows me to be able to tell you to follow that pattern, but there's not a block of digits that gets repeated. So that's going to be on the irrational side. If I change that up a little bit, if I did 4.1, maybe 1, 0, 1, 0, 1, 0, 1, 0, 1, where what I'm repeating is this block of digits. Okay, oops, let me, okay. And I kept going, which would be 4 point, and I could just say I'm repeating that block of digits, maybe the 0, 1, I could put a bar over. Okay. That would belong on the rational side, just that slight change. Okay, and then one other thing I would like to do is just let you know there are other types of numbers. This is all we'll need to know for now, but even in Math 100, we have to expand the number system. We have to look at not just real numbers, but numbers that are considered imaginary. And the real numbers and the imaginary numbers make up the complex number system. Okay, and imaginary numbers, somebody made them up because we needed to have an answer to something like that, the square root of a -16. You can't find a number times itself that equals -16. We had to make up this number, we call it I, that stands for the square root of -1, and square root of -16 would be the imaginary number for I. All right, so they sometimes look like this, like 3 plus 2i over 7, stuff like that. Anything with an I in it, and it comes from having negatives under things like square roots. Okay? All right, so that's probably enough of that. let's go back now and try to work the problem on the worksheet. So we're supposed to be taking this list of numbers and indicating, which of those numbers are natural numbers. So we're looking for which of the numbers are in that innermost box. That's super nice. They're sometimes called the counting numbers. There's really just one. It's the number 3. Okay. And then whole numbers include all the natural numbers, but then also 0. So the whole numbers would be 0, but don't forget to write the 3 again, because 3 is a natural number, but it's also a whole number. Okay. And then look at how the integer box, see how the integer box here goes all the way around and includes the whole numbers and the natural numbers? Make sure that when you answer these questions, you realize that. So like integers would be the 0 and the 3 are also integers, but we can also include the -5 and the -1. Okay. And all of those would be integers. Okay. And all of those integers would also be rational. Okay. So all of those would be rational as well. Let me do this differently though. I want to take that big set and just kind of do them in order. The order you put them in does not matter. I just thought it'd be easier if I was looking at this set of numbers and just going through and listing which are rational. So -5.3 is rational because the decimal terminates. -5 is because it's an integer. But see, negative square root of 3 would not be rational. Let's go ahead and do these two at the same time. If you have a real number, it's either going to be rational or irrational. So negative square root of 3 belongs in the irrational pile, because if you did the decimal for that, that decimal would keep on going, would never terminate and never repeat. Okay. -1, that belongs on the rational part. -1/9 does. Any fraction is rational. The number 0 is a whole number, natural number, not a natural number, I mean, it's a whole number, and an integer. It's also rational. Now here we have a 0.27, and the bar over the top is telling you that decimal repeats, which puts it up here. So that 27 getting repeated like that makes it rational. Actually, it would be equivalent to 27/99. Right, 1.2 is a decimal that terminates. 3 is a counting number, so it's also whole and it's also an integer. It's also a rational number. And then the square root of 11, that's going to be down here in the irrational box, because that's a decimal that, a number that would have a decimal that never stops. Okay, right, and then when you get to the real numbers, none of the ones that in this list were imaginary, were they? All of those, all of the numbers is what you'd list. Every single one of them. Wouldn't matter the order. But all of them, whether you're rational or irrational, you're still real. So that whole entire list, all of them is what you'd put. All of these. Okay? All right, let's go back to the homework now. I want to do a problem out of the homework for 1-3. And I want to look at 2 questions. One of them where I'm doing a number line. Let me see if I can find the one I want. Let me go do a similar. We'll go ahead and do this one. This is kind of like what we just did. Okay. So I'll do the actual problem without snipping it. All right, so this problem says, list all the numbers that are all these different types, okay? So out of this list, I'm supposed to choose the natural numbers from the given set, and I'm going to choose all of the numbers that are natural. So 4, I just click in the box, and looking at all the rest of these, it's the only one, okay? So once you do that, I'm going to check my answer, and it'll give me the next question. Okay, that one says choose which of the numbers from that set, and that they've got them all listed, and you just click on all the whole numbers. So 0 is a whole number, so is 4, but that's it from that list. Okay. Right now it's asking me for integers, and integers aren't just negative numbers. Okay, sometimes people make that mistake. Integers still have to be really nice. You can have a negative like a -5, or you can have a positive like a +4 or 0, but you can't have fractions and decimals that don't simplify to be really nice. So those are the only integers that I see. Okay. All right, now move this up. Now it's wanting rational numbers. Okay, so rational numbers, that's on the left side. Now, those would include fractions that are positive or negative. It would include decimals that stop. It would include nice numbers like 4. Here's a decimal that terminates. 0 would be rational. -5 would be. But the square root of 3 would be a decimal that keeps on going. So that's not rational. Okay. All right. So now it's asking me for irrational. So like I just said, notice on D, everything is checked except the square root of 3. So for irrational, the square root of 3 is the only one. Okay. And then it's asking me, okay, which of the numbers from the set are real? And that would be every single one of them. All right, so that's how they asked the question in my math lab on that. All right, now I want to go to the previous question, which was asking me to use the number line. So let me see if I can just get to a new problem. Let me just quickly want a similar question. I want to start over. I had done part of it, so let me just kind of start over here. Don't pay attention, don't look at it yet. There we go. Okay, let's start fresh. All right, so what's going to happen on question number 4 is you're getting a bunch of numbers and they're asking you to indicate their location on the number line. So you have to use this number line tool. So what's going to happen is you're going to put your cursor there and either use your mouse to hold it down or use your touchpad to hold it down, and then you can pull it right or left. So to plot 3, 4, see how they broke it up for me nicely into 4, broke up that unit into 4 spots. So this would be 1/4, 2/4. There we would have 3/4. And then I can check my answer. Okay. All right, now it wants me to plot 4.5. So I'm going to grab that by clicking on it and holding it so I can move it. And I'm going to go to 1, 2, 3, 4 whole numbers and then an extra half. Check my answer. Okay. -1.8. See how they broke it up? They've got it broken up into tenths. 1/10, 2/10, 3/10, -4/10, -5/10. I have to go negative all the way to 1, and then I have to go to 8/10. So -1.1, 2, 3, 4, -1.5, 6, 7. Here would be -1.8. Okay. All right, -7 is easy. We just move it till we get to -7. And then we have another one with 8s, -1 1/8. I would slide over to -1 and go 1/8 past it. And see, let me look at this. See how they did 1/8? You have 1, 2, 3, 4, 5, 6, 7, 8 pieces. So I just go 1/8, 1 past it. This would be 2/8. This would be 3/8. This right here is 4/8, but 4/8 is the same as a half. So that's why that would be -1.5. All right. So those are the ones I wanted to show you. And that should get you to where you can work on that homework. That's the hardest part, is the real number system part. So let me stop this and get it posted.